The topic is finding the domain of functions. Alright, so let's do example 1. Find the domain of f of x equal 1 minus e to the x squared divided by 1 minus e to the 1 minus x squared. So remember the definition of the domain. The domain is the set of all x's such that f of x is defined. What do we mean with define? We mean it's a real number. Think of what are all the x's such that all this quantity is a real number. So it's a rational function. If it's a rational function, all we don't want the denominator to be 0. So in other words, the domain is all the x's such that 1 minus e 1 minus x squared is not equal to 0. If we can find all these x's, we're done. So let's solve for 0 and then we get rid of those x's. What does it mean 1 minus e 1 minus x squared is equal to 0? It means e 1 minus x squared is equal to 1. Right? How do we get the exponent? Take ln of both sides. Right? So ln of e 1 minus x squared is equal ln of 1. But we know ln of 1 is 0. Ln of e to something, let me write ln of e x is equal x. So 1 minus x squared, right, is equal 0, which means x squared is equal 1, which means x is equal minus or plus 1. So these are the numbers we don't want. So therefore, the domain will be all the real numbers except those two. Negative 1, union negative 1, 1, union 1, infinity. Right? So that's the domain. Alright, so let's do example 2. Same thing, the example 2, it's a rational function. So the domain will be all the real numbers such that e to cosine of x is not equal to 0. We know e to any number. Here's a graph of e to the x or e to the u. Right? So this is e to the u. Let's call this a u or a x, doesn't matter. Y equal e to the u. So e to something is always, e to the u is always strictly bigger than 0. So we know that e cosine of x cannot be 0, strictly bigger than 0. So therefore, domain is negative infinity, infinity. Right? In other words, for all x's, this is never be equal to 0 because it's always strictly bigger than 0. Alright, now let's look at the next example. Well, this one is obvious. Sine of x. Well, x could be, what's the domain of a sine of a number? That number could be anything. So basically, this is so obvious. The domain would be negative infinity, infinity, right? Because we don't have anything in the denominator. We don't have no square root, nothing. So domain is all real numbers. Alright, now let's do this example. Now here, since we have a radical, so the domain will be all the x's, right? Such that 1 minus 2 to the x is bigger or equal than 0. Right? For this f of x to be defined, we need whatever under the radical to be bigger or equal than 0. What does that mean? That means, let me rewrite it. 1 minus 2 to the x is bigger than equal than 0. That means minus 2 to the x bigger or equal than negative 1. Divide by negative 1. Switch the symbol. Now take log 2 of both sides. Right? Now we need to use this equation. Log b to the x is equal x. So this becomes x. Last equal log 2 of 1 is 0. So therefore the domain will be negative infinity to 0. And that's it for this example.